Yeah, it's time to talk about carbon and to make the connection with electricity efficiency. And as I think you'll see, the connection is actually very intimate. But I'm going to start with the Carbon 101 tutorial, okay? The atmosphere is actually a fairly simple place for the purposes of this subject. There's a certain amount of carbon dioxide in it right now, 3,000 billion tons. That's the black number. Roughly 1800, but also about 1000 AD, there are about 2,200 billion tons of carbon in the atmosphere. That's the green number. The blue number is at the depths of the ice ages, including, say, 30,000 years ago, there were 1,500 billion tons of carbon in the atmosphere. So we are as far above the carbon dioxide of the warm period of the glacial cycles, which is where we are now. We are as far above that number as the depths of the ice ages is below that number. The ice ages show a regular pattern. I don't have time to show you a picture, but 6 cycles of 100,000 years each, during which the carbon dioxide went between those two numbers. And now we are in an unprecedented territory in terms of the development of our species, as far above as the depths of the ice ages were below. The fourth number, at the red number, is double the pre-industrial concentration. The number 2,200 is the reference number. It was constant for a long time before we started changing the atmosphere. And so we talk about twice the pre-industrial concentration. That's 4,400. And we see that another way of thinking of where we are in this room today is 1/3 of the way to doubling. Doubling is where a lot of the political argument has been centered over the last 20 years, largely saying these days it may not be strong enough a goal to accept doubling. Maybe we need to do better than that. But out of that model comes a view of a certain amount of additional headroom to be used by the people of the world with concerns for across the countries of the world and present versus future generations. A certain amount of headroom to be used up. The red line is, of course, going to be itself a political argument as we figure out where that is. There's a second unit on that slide in parentheses, the more common unit for discussing this, which is parts per million. There are 380 parts per million of CO2 in the atmosphere today. That means that as you took your last breath, 380 out of every million molecules were CO2 molecules. Those parameters are proportional. 7.7 billion tons of CO2 as a part per million. The third unit that's out there alive and well is tons of carbon. Most of you know how to go between a ton of carbon and a ton of CO2. Since carbon is 12 and oxygen is 16, so 12/44 is that ratio. So that's part of what keeps people out, is 3 different units proportional to one another, always in each other's way, journalists getting confused and whatnot. The flows into this atmosphere are about 30 billion tons a year right now, 1% of the stock. And roughly half is staying in. There are 2 drains in the bathtub. One is going into the ocean. One is going into land, which overall is growing in its carbon content. In spite of deforestation, which would be a green arrow upward, there is a net absorption of carbon into the plant matter of the planet. Not fully understood. That number is really calculated by subtraction, because one can get a direct measurement from ocean models with some confidence of how much goes into the ocean, primarily at the surface, and as many of you know, changing the ocean in the process, becoming more acidic in particular. So we have a pretty good handle. And for the purpose of this talk, I want to focus on the 30 billion tons per year. That is what we are taking out of the ground as carbon, 12/44 of that, 8 billion tons a year of carbon comes out of the ground, goes into the atmosphere in the form of 30 billion tons of CO2. First, though, let's discuss why anybody is likely to act. The politics of this problem has got to be that people decide they don't want to let the carbon dioxide concentration keep growing. And certainly 20 years ago, people who thought about this didn't think we would have the will to stop below doubling, for example. There's been a change in the sense of urgency in the community of humanity as a whole. What will drive a change? Will it be gradual climate change? That is what's measured primarily, 1 degree Celsius rise in temperature, 2 degrees, and so on. Will it be extreme events? Will it be harm to the ocean? Will it be sea level rise? Will it be damage to the non-human species, like the polar bear, and the balance of nature in various places? Or will it be disease vectors? I have in talks where I have an hour instead of 25 minutes, I actually have you vote on two things. One, which of these is going to drive, would you have, do you feel should drive the system most, then would you care most about it? And then what is your judgment about what the populace as a whole thinks about this and will drive the politics? And they're actually, my experience is all of these get votes, and there are always systematic shifts depending on the audience. I wish I had time to do it, but I don't. So keep that in mind, have a private vote, and let's keep driving on. Sea level rise is extremely interesting. Things are happening in the Arctic that are faster than the models predict. The modeling groups over the next 5 years, I learned the last few days, that are part of this IPCC process are going to try to model the Arctic as best they can with every model that anyone believes in to try to understand what's happening. The ice caps are shrinking, and this picture of 2005, I will quickly update because the 2007 shows considerably less, I think 20% less ice than in that 2005 picture. And unprecedented, not fully understood. Reversible, no one is sure. That doesn't directly lead to sea level rise, as you know, because that's floating ice, but it changes the whole regional climate and what will follow from there. So a final picture on impacts. I think this is a dramatic one, especially in terms of American politics. There are 4 different rises of sea level as they affect the topography of the southeast of the US. And by 8 meters, Florida has pretty well disappeared, and that's some very valuable real estate. The southern half of Florida, if anybody lives in the northern half, not every bit disappears. And it took me some time to learn how to interpret 1, 2, 4, and 8 meters. When I learned that there are 2 parts of the planet where people are seriously considering the potential that over a couple of centuries, one would in fact have a major ice mass disappear that is not floating. The Greenland ice sheet, 7 meters worth. The West Atlantic ice sheet, which is about 10% of Antarctica, 5 meters worth. So there are things there will be continual pressure from the science community, learning about a new effect on the political process, saying, do we really want to live with this? Are we sure it's going to happen? No. My colleague Steve Socolow acknowledged in that opening slide where we wrote these papers together on a topic I'm showing you in the next slide, he calls these monsters behind the door. I like that phrase. The sea level rise is a monster behind the door. Losing the Amazon, shutting down the Gulf Stream, major droughts in certain critical areas, monsoons. There are nasty forecasts that all of which have an unknown probability, and the extreme is not that likely. So that the whole model here is purchasing insurance against outcomes one cannot really rule out that are perhaps individually of low probability. And the aggregate is proving, I think the evidence of the last year or two is when people understand that this is a risk they maybe don't have to run, they get very interested in not running it. Obviously, the implications are for this meeting at that point. So let's go back to that 30 billion tons of carbon going into the atmosphere per year as CO2, 30 billion tons of CO2 going into the atmosphere. And let's first of all look backward. And back a little more than 50 years, it was 1/5 as much. The carbon activity, which means the coal, oil, and gas activity, has been growing at that sort of a rate. Somewhat linear, but 5 times bigger in just 50 years. So that's why we weren't thinking about it, or your parents' generation wasn't thinking about this problem very much, say, in that time period. All that white space on the right is to pose 2 questions for you. One is, if we do nothing about the carbon problem, or nothing serious, and sort of lose interest in it as it looks harder than we first hoped it would be, what will be the carbon emissions 50 years from now? There's an immense literature on that subject. It uses the methods of econometrics. It assumes a growth rate of the economy. It assumes penetration of various technologies, low carbon technologies and whatnot, developing country growth rates, and there's a whole sea of answers. There's a second question, is if we really want to take this carbon problem in hand, what would be a level of effort which we should feel proud of ourselves making? And again, in order to deal with the carbon problem, another thousands of papers. What